So letter D, like I said, is double angle formulas. Formulae. So one thing I just wanted to tell you guys before we get started is that all these formulas are in your packet. And for some of this stuff, I'm going to talk about like two different ways to get to your answer. Like the formulas are the formulas and that's that. But then when you want to find sine and cosine, there are ways you can find that algebraically and there are ways you can find that sort of geometrically. So I'm going to talk about both ways and then I don't care which way you guys solve that. Did everyone get their Stepbox? And in the Stepbox is where I'm really going to break it down into like both ways. So I'll kind of like do it throughout the notes, but really break it down for that Stepbox. Excuse me. So here are our double angle formulas. So for the sine of 2 theta, the formula is just 2 sine theta cosine theta. So for example, if theta is 60, what's 2 theta? 120. So that angle becomes twice as big. So if we have the information, like if we know sine and cosine for a 60-degree angle, we can find sine for a 120-degree angle using this formula. For the double angle formula for cosine, there's actually 3 different versions of this formula. So one version is cosine squared minus sine squared. That one kind of comes up in the notes more than these other two. But the other versions are 1 minus 2 sine squared and 2 times cosine squared minus 1. And where this comes in handy is like if you have a problem that only tells you sine, yes, you guys can find cosine, you've done that before, but if all you know is sine and you need the cosine of the double angle, you can actually just plug that in, so that's why that's kind of helpful. It'll just give you less work on some problems. And all 3 of those are listed in your formula packet, but instead of being listed like in a list, it's just like separated by equal signs. So I would definitely make sure you can find these in your formula packet. They are exactly under this other popular one. That's one that you might choose to use today, as well as the tangent one you might choose to use today. Okay, are we all good with the formula? I just like saying formulas, but I don't know, the book calls them formulae. All right, so do you guys remember this with our unit circle? What does ASTC mean? I mean, I'm not talking about a smart trade class or a silly turtle crawl, but what do they mean? Yeah, which ones are positive? So in quadrant 1, all of our trig functions are positive. Quadrant 2 is just sine, 3 is just tangent, and 4 is just cosine. And so we will use that to make sure we know like if our sine or cosine or tangent are positive or negative, because they might give us an interval. Like it might say that our value is between pi and 3 pi over 2. So it might tell us that our angle is in this quadrant. And so that will be helpful for finding those signs. And then this is sort of a geometric way to solve for some stuff. So let's say that we have this angle, so I'm going to just call that angle x. We've got a right angle here. So we know that this is opposite, and this is hypotenuse, and this is adjacent, right? So Katoa, we all remember that. So I'm going to sort of make up a number here. It is not going to be drawn to scale. All right. So let's say I said that the sine of x equaled. Actually, I'm going to go with equals 12/13. How could you put those numbers 12 and 13 on that picture? Where would they go? Very good. So 12 is on the opposite side, and 13 would be on the hypotenuse. So let's say my question was, what's the cosine of x? I could just find this adjacent one, and then I could find that cosine. So this is like the geometric way to do this in case you like it. Because how would you find that missing side? Absolutely, you could do Pythagorean theorem. So 13 squared equals 12 squared plus a squared. So 5 equals a for that adjacent side. So then we can just go ahead and say that that is 5/13. So that's one way to do this. The other way I'll mention, because we've done it before, excuse me, but another thing you're going to notice is like, yeah, that was kind of a pain, I guess, maybe to do Pythagorean theorem. I don't think it's that bad. But you'll see a lot of those families, like this is a 5, 12, 13. So some of you might have looked at the 12 and 13 and knew right away it was 5. Or like 3, 4, 5 is a really popular one that comes up, or multiples of that, like 6, 8, 10, and any multiple of that. Just got to multiply all three numbers by whatever that multiple is. So it'll go quicker once it's like those numbers you remember. If you don't like any of this business, the other way to do it is to use that trusty old cosine squared plus sine squared equals 1. So you could always do cosine squared plus, what was that, 12/13 squared equals 1. And you will get the same answer as we did. So this is sort of like the algebraic way to do it and more of a geometric way to do it. So those two different approaches, and it's really what's most comfortable for you. For me, I spent a long time always using this one because like the algebra just made sense to me. But then Miss Krantz is like, sometimes it's quicker if you do the triangle. So I wanted to make sure that we talked about that as well. We're going to get into some examples with those formulae next. Any questions? Okay. All right, oops, I don't want to get that zoomed in. So here's our first example. Sine of beta is -3/5, and cosine of beta is -4/5. Find sine of 2 beta, cosine of 2 beta, and tangent of 2 beta. So if we start with just finding sine of 2 beta, I'm just going to write down the formula. The formula was 2 sine beta cosine beta. So then I can really just take this, plug it in for sine, and I plug that in for cosine, so I have 2 times -3/5 times -4/5. So I really just plug those both in. Now, yeah, sometimes it is a little bit more work because maybe they'll only give you sine, and you did that work we were just talking about to do cosine or something like that, but it's not that bad to just plug those numbers in, even if you have to find one first. Any questions where any of those numbers in blue came from? So then we can multiply these. So if I multiply my numerators, negative 4 times negative 3 will be positive 12 times 2 is 24, and 1 times 5 times 5 is 25. So that is sine of 2 beta. For cosine of 2 beta, there were 3 different formulas we can choose from. Every single one works because we've got sine and cosine. So do you guys have any preferences? Should I just use the first one? Is this the first one? All right. So that was cosine squared beta minus sine squared beta. And I don't recommend doing what I just did, trying to go from memory, especially because you guys haven't been doing this as long. So let's double check. Yes, I got it. So now we plug these values in again, but keep in mind it's cosine squared, so I have to have, move it down here for my work, negative 4/5 squared minus negative 3/5 squared. And you will, as long as you are using your algebra correctly, you will get the same answer if you chose the second formula or the last formula. It does not actually matter. So when I square these, I square both the numerator and the denominator. So negative 4 squared is 16, and 5 squared is 25. Negative 3 squared is 9, and again, 5 squared is 25. Nice that we've got some common denominators because we can just now subtract our numerators, and 16 minus 9 is 7. All right, let's kind of stick with our algebra for a second here before we talk about the geometric way to get our final answer. What's the formula we already know about tangent? Sine over cosine. I mean, it works for tangent of 2 beta as well. So tangent of 2 beta is sine of 2 beta over cosine of 2 beta. Just don't use your original ones and try to do something with that. So we'll have to use both of our answers to do this because 2 beta is just a number. It's just twice the original number. So I end up with 24 25ths divided by 7 25ths. And I just continued my work right away and multiplied by the reciprocal. So my answer is 24/7 for tangent of 2 beta. What are you guys thinking so far? It's not too terrible, I hope. Now, if for tangent, and actually this would probably work for cosine as well, but I want to use that formula. If I draw just a generic triangle, and let's say that's beta, and I put sine is, opposite over hypotenuse, and my cosine was adjacent over hypotenuse, so that matched up, then again, it makes sense that my tangent is opposite over adjacent, 24/7. So there are ways that you can use like your geometry skills, or you can use your algebra and trick skills here.
How do we know it's a right triangle?
What do you mean?
Because tangent we do so if we talk about right triangles.
So because it says sine equals that, that's where I'm drawing that right triangle. I know where you're going with that.
Let me see if I can think of a better way to explain it. But I can do that because it says like it's sine and cosine, and we didn't start with a triangle. Okay, so let's just try another one here. It says that the tangent of x is negative 3/4, where x is between 3 pi over 2 and 2 pi. And then kind of the same question. This is a typo. These should match that variable, so just change that to 2x for all of these, because it should really, the variables should match. So instead of 2 beta, you should just do 2x for all those. So if we take a look at this, which quadrant are we in? Between 3 pi over 2 and 2 pi, which quadrant are we in? And if you want to look at your unit circle to help, there's nothing wrong with that. Very good. Quadrant 4, because here's 3 pi over 2, and here's 2 pi. So we are in quadrant 4. So we know that our tangent's negative, our sine will be negative, but our cosine will be positive. So that will help us moving forward. Now, if you want to just draw any old triangle, you can, but I'm going to draw a right triangle actually in that quadrant. So again, I know tangent is opposite over adjacent, so my opposite side is negative 3 and my adjacent side is 4. So what's my hypotenuse? You guys remember this special one? Yeah, 3, 4, 5. Now, if you forgot that that is going to be 5, then do Pythagorean theorem, okay? Like, there's no one stopping you from doing Pythagorean theorem if you come across some numbers that you just don't remember or aren't sure about. But it is indeed a 3, 4, 5, so that means I can figure out sine of x and cosine of x pretty easily here. So sine is opposite over hypotenuse, so that's going to be negative 3/5. Can you guys see it on that gray? Like maybe I'll just write it in the corner here. Which makes sense. Remember we said it's got to be negative in that quadrant. And then cosine is adjacent over hypotenuse, so 4/5. Sure enough, it's positive in that quadrant. Okay. Want you guys to find sine 2x, cosine 2x, and tangent 2x on your own. So you can use the same formulas that we used last time. You can do tangent algebraically or if you want to. You can use a different formula for cosine if you want to. But I'm going to give you guys a few minutes to try those on your own. You will end up with similar numbers, but that's okay. you guys get for sine of 2x? Yep, I did too. I was looking at the wrong problem for a second, like so the numbers are so similar, and I was like, wait. Alright, flip to the negative. Alright, what about cosine of 2x? Did anyone use a different formula than the first time, or does everyone stick with cosine squared minus sine squared? Are you guys, there are no like other examples, so do you guys want me to use an alternate formula? Do you want to see that? Okay. It was just a question that was asked last hour, so I got to put up there. All right, what about tangent of 2x? Negative 24 7. So, for tangent, how many of you guys drew a triangle? How many of you guys used the formula sine over cosine? How many of you guys just didn't ever do it? Okay. So we are going to talk about something just a little bit different than this stuff coming up next. So are there any questions about using these formulas? Okay. So the next piece, it has to do with like simplifying. And it says, use an appropriate double angle formula to simplify. So it tells us to use one of those formulas. We've got 10 sine x cosine x. I know that this section on the assignment can get a little frustrating, but the more you do it, the more you start recognizing relationships within the formulas and the numbers, and that's helpful moving forward when we work on simplifying. So what I would do is I would look at the formulas. So we got 4, right? Because cosine had 3 versions. So does this look like at all similar to any of the 4 formulas we wrote down today? Which one does it look like? Good. Sine of 2 theta, or whatever variable it is. So it looks like this one. Sine of 2x equals 2 sine x cosine x. I wrote that at the bottom because that's more of like what we're thinking. That's not necessarily part of the work. So would you guys agree that that kind of looks like that formula a little bit? So what we want to do is see if we can somehow rearrange or rewrite it so that I can get something that looks exactly like this, and then I can substitute. Well, I noticed that 10 is an even number. So I can write 10 as 5 times 2, and then I still have sine x cosine x. And then I can go ahead and plug this in right for this. So I have 5, not s, 5 sine 2x. And that is the simplified version. So the more of these that you work through, the more you'll start to recognize those relationships and go from there. But check the back of the book if you're not getting it. Take a look again. If you're still not getting it, then let me know. Maybe there's just something that you need help seeing. Okay, so that's okay. If you need some help seeing some kind of relationship, that's one of the things I'm here to help teach you. But some of it you gotta just try on your own and then ask. So the step box is sort of like a little problem. Like, if you know that the sine of x is 6 over 10, and x is between pi over 2 and pi, how can you find cosine x and tangent x? Like, what could you do? Alright, so Pythagorean theorem. So that's kind of like the geometry way. So if I have my coordinate plane and I'm in this quadrant, it's from pi over 2 to pi. So I could draw a triangle over here. So sine, remember, is opposite over hypotenuse, so I'd have 6 over 10. And I can do Pythagorean theorem, or this is one of those special relationships. It's a version of a 3, 4, 5, but all times by 2, so that's an 8. except for that's going to be a negative 8, right? Do you guys see that? Because that's the side of that triangle I'm on. If that doesn't make sense to you, you could always think about the fact that in that quadrant, only sine is positive, so my cosine and tangents will be negative. So cosine is negative 8/10, and not sine, but tangent will be negative 6/8. So you can do it that way. If you don't like that way, what's another option? The triangles and the sines aren't working for you. What's your other option? Some of you guys used it in the last problem? I thought, well, no, you kind of use the tangent one. You could always use cosine squared plus sine squared equals 1. So yes, I know those numbers can be reduced. I know I didn't say that. But this will actually also work. So you can go ahead and find that. So I'm just gonna, we've done this before, so I'm gonna go through this pretty quickly. So that would be like this. So when I square root it, I would get plus or minus 8/10. But because cosine's in this quadrant, I know that it would have to be negative 8/10. So if you don't like the geometric way, go ahead and do the algebra way. Again, that's old news. We've done that before, and like I said, I think chapter 8. And then we can get tangent by doing sine over cosine, just like we've done, earlier today, and end up with the exact same thing. So again, whatever way works for you. I feel like this way looks like more work, but whichever way works for you is completely fine with me. Do we have any questions before we put the assignment